So this was a weekly homework exercise related to topic moment, page 1 to page 10. You can ask your doubts. For page number 3, any doubt? Page 3. Because the questions are not in sequence, that's why I'm mentioning the page. Page 3, any doubt? Page 4, any doubt? Page 4, part B, okay. So the spring in the question, the spring obeys the Hooke's law and elastic's potential energy is 0.32. But calculate the compression. So if you want to compare the compression or the extension, recall the formula that energy stored in the spring is half force into extension or force into compression. Or if the spring constant is given, so it will be half kx square. Or if force is given, so it will be half f divided, like, because f is equals to kx is there, but usually we don't use that. For usually extension is there. So we have the energy which is 0.32, and extension we need the extension. How much force is applied on this spring? So in the question, compressed spring exert a total force of 8.2 newtons. So we have the total force which is 8.2 newtons. So we just use the formula that energy stored in the spring is half F into X. So energy is there 0.32. We have the force which is 8.2. So we can use this formula to work out the compression of the spring. Compression or extension both can be calculated by this formula. Page 5, any doubt? Page number 5. Page 5. Page number 6. Part E. The block is now moved closer to end A. Assume that the beam remain horizontal. State whether this change will increase, decrease, or have no effect on the horizontal component of the force exerted on the beam by the hinge. So in the question, what we did, this block is there and this block is moved more towards the pivot. So we have moved to closer to end A. Look, if you compare the turning effect, this weight is causing a clockwise turning effect. This 12 Newton is causing an anti-clockwise turning effect. And there will be component of the tension, like tension T is there. This will be T cosine and T sine. So these components are causing, this is causing an anti-clockwise turning effect. And the T cosine is in this direction. So the clockwise and as the block is moved more toward, like block was placed here. So it was causing a greater turning effect. But then what will happen if I move the block a 12 Newton closer to the pivot? So as a result, the turning effect of this 12 Newton turning effect will decrease. If the turning effect of the 12 Newton will decrease, what should happen to the tension? It has a fixed angle, but it remain horizontal, so angle is not changing. But what should happen to the tension? The tension should also decrease. Why the tension should decrease? Because if the tension remains the same, then the component of the tension, which was this T sine 50 degrees, and the horizontal component, which is T cosine 50 degrees, if that does not change, if the tension does not change, it means that this turning effect should be greater and the beam should be lifted up. But they mention in the question that the beam remain horizontal. So if the beam remain horizontal, it means the clockwise and anti-clockwise turning effects are still equal. So if we reduce the clockwise turning effect, the anti-clockwise turning effect should also be decreased. And how the anti-clockwise turning effect will decrease? So the tension or the value of a T should decrease. And if the value of the T decreases, what will happen to the horizontal component? The horizontal component will also decrease. So here the answer is that the value of as a like the object A is moved closer towards like mass 12 Newton is placed closer to point A. So the clockwise turning effect will decrease. So the anti-clockwise turning effect will also decrease. And to decrease the anti-clockwise turning effect, the tension or the value of the T should decrease. And because the T cosine 50 is balancing the force on the beam, because it is balanced, so there's a force here. So T cosine 50 is balancing this horizontal force. So this horizontal force should also decrease. Because the question was the horizontal force on A. State whether in effect horizontal component of the force exerted on the beam by the hinge. Is it clear? So this is a horizontal component of the tension and this is a horizontal component here. So when I bring this closer, the clockwise turning effect decrease, the anti-clockwise turning effect should also decrease. So it means this T should decrease, the tension. When the T decreases, the horizontal component of the T is T cosine 50. Because it remain horizontal, that's why the theta is not changing. So if theta is not changing, the value of the T should decrease. So if the value of the T is decreasing, the horizontal component will also decrease. Is it clear? Next is page, this was part E. Then page 7, any doubt? Page number 7, part B. This part B. A uniform rod is there. A rod has a length of 4 meters and 44 Newton. By taking the moment about P, so P is the point of rotation or a pivot, calculate F. So this is a point of rotation. Which direction this will cause a rotation clockwise? Which direction this will cause a rotation clockwise? And which direction this will cause a rotation anti-clockwise? And whenever we are solving a question, we consider it is in equilibrium. So the total clockwise and anti-clockwise moments or turning effects will be balanced. So this is F, the force F is there, and we always take a distance from the pivot. So what is the distance from the pivot? It is 1.1. This is the force is 44. What is the distance from the pivot? Because 1.7 is a total and 1.1 here. So how much is this distance from the pivot? So when you subtract, it will be 0.6. So it will be 44 into zero point 0.6. And what about this turning effect? The force is 3 Newton. This distance from the pivot, if this is 1.7, so 4 minus 1.7, so this will be 2.3. So this will be 3 into 2.3, which is also causing a clockwise. So the total clockwise will be equals, sorry, distance from the pivot I have to take. So this distance is this one I have to take. So the distance from the pivot I have to take, so this will be this is 1.1. So remaining will be 2.9. So this will be 2.9. So the clockwise and anti-clockwise turning effects will be equal. F into 1.1 is equals to 44 into 0.6 plus 3 into 2.9. And then you will make a subject F and just divide. You will get the value for F. Like 1.1 will be divided. Is it clear? This one? Part B2. calculate the force exerted on the rod by the pivot. So whenever we need the force, like we calculated this value, F, we calculated this F, like example, say this is 32. So whenever we need the force on the pivot, the total upward force equals to downward force. So the downward force is 32, 44, and 3. They are all acting downward. Because it is balanced, so the total upward force must be equals to downward force. So upward force is the force of the pivot on the rod, and the downward force is 32 plus 44 plus 3. So you just add them. 32 plus 44, so it will be 66 plus 3. Sorry, 76 plus 3, so it will be 79. So the force exerted by the pivot, it will be 75 Newton, and direction will be upwards. Page 8, any doubt? Page number 8. Here, use Archimedes principle to determine what is the Archimedes principle. It states that the weight of the liquid displaced is equals to the upthrust. So upthrust is equals to weight of the displaced liquid. So an upthrust is equals to density of the liquid, volume of object, and gravity. Like when it's not like volume of object, it is a volume of displaced liquid. But when object is completely submerged, the volume of the displaced liquid is same as the volume of object. That's why I wrote here. So first we'll find the volume of object here. The upthrust is given 2.5. So this is given 2.5. The density is 1100. So density is 1100. Volume of the displaced liquid is same as the volume of object, and the gravity is 9.8. So 2.5 divided by 1100 into 9.8, that will give us the volume of object. After finding the volume of object, what is this object? It's a sphere. So volume of sphere is given by a formula 4 by 3 pi r cube. So by this you got the volume. 4 is constant, 3 is constant, pi is constant. So you can work out the value for r. Then for second part, calculate the magnitude and the direction of a resultant moment. Look, this rod was in equilibrium first. Now because of the upthrust, because like this was causing a, initially this was causing a anti-clockwise, this was causing a clockwise, and the weight is also causing a clockwise. So it was balanced. But now what happened when it is placed in a liquid, there's an upthrust. So it means upthrust is causing a turning effect. Because it was balanced originally. When we place in a water, a liquid, which is density 1100, that is applying an upward force which causes a turning effect. So if we just need the turning effect of the due to the upthrust, and that is a resulting turning effect. Because rest all of them were balanced. The weight of the sphere, this weight of the beam, and the force, they were balancing each other, their moments. So now the turning effect is only due to the upthrust. So the upthrust is given 2.5. And what is the distance from the pivot? This point was, because if this was originally this distance from the pivot, it was 1.1. So this is 2.9. So this distance is 2.9. So what we have to do, just 2.5 multiplied by 2.9, we'll get the resulting turning effect, which is 7.3 Newton meter. And which direction it will cause this turning effect? It is anti-clockwise, as you can see, opposite to direction of clock. Is it clear? Or there's also another way you calculate the turning effect of this one, turning effect of this one, turning effect of the upthrust, turning effect of this force, and then subtract. How is just upthrust moment is a resultant? Because the beam was balanced originally. If you see this question, the beam was balanced. So if the beam was balanced, this was causing a clockwise, anti-clockwise, this causing a clockwise, this was causing a clockwise, and this was balanced. But when it is placed in water, the upthrust is actually causing a turning effect. So the resulting turning effect is now only due to upthrust. Or you can also solve in other way, like you calculated this is 32 Newton. So this is causing an anti-clockwise turning effect. Upthrust is there 2.5 Newton. That is also causing a clockwise, anti-clockwise turning effect. This is causing a clockwise and this also causing a clockwise. So 3 into 2.9, this will be 2.5 into 2.9. This will be 44 into 0.6. So find the clockwise. These two are the clockwise and these two are the anti-clockwise. And just subtract the clockwise and anti-clockwise. Just find which is higher value. So you'll find that the anti-clockwise is higher value and you'll get the same answer. So both ways can be used to do this. Directly take the upthrust or take a resulting turning effect. Find the total clockwise and total anti-clockwise. Is it clear? Page 9, any doubt? Page 9, part B. Show that the mass of a sphere is 0.3 kg. So in the question, the sphere swings from one side to another at an instant. The sphere is at lowest position x, and its kinetic energy is also given to us. And the momentum is also given 0.72. The short time later, the sphere is at position y when momentarily stationary. Uh, the string has a mass of a fixed length and negligible weight. The air resistance is also negligible. Show that the mass is about zero point 0.3 kg. So what is given to us? Given to us is momentum, and given to us is a kinetic energy. What is a formula which relate the kinetic energy and momentum? If I want to relate the kinetic energy and momentum with each other, look, I did this derivation, a short derivation in the one more question. It say kinetic energy is half mv square. If I multiply and divide this equation by m, so kinetic energy will be half mv square multiply and divided by m. So what it will become? It will become m square v square over m. So kinetic energy is mv whole square divided by 2m. So I can also say kinetic energy is equals to momentum is a product of mass and velocity. So it is p square over 2m. So this is a formula which relate the kinetic energy, momentum and mass. So kinetic energy I can do by calculation as well. Like first using a kinetic energy, I will find the speed or compare the two. No, this is a formula, the direct formula. I don't have to derive a formula here. Directly, I can use this formula that Ke is P square over 2m and I can find the mass. I just have to substitute the value. So mass will be equals to P square over 2 into Ke or Ek. So I have the momentum, I have the kinetic energy, I can just substitute and I'll get the mass. So I'm not saying derive this whole formula for this question. I'm saying this formula, recall this formula so you can use it to solve a question. Then calculate the height C, D, E. Any doubt? The last page 10, whole page. Calculate the height. So if you need the height, you have to assume that the kinetic, if there is no loss of energy, the kinetic energy here is equals to potential energy. So the loss in Ke is equals to gain in potential energy. So mgh is equals to half mv square. M will cancel with m. So gh is equals to half v square. So you have speed at which it was moving because you have the kinetic energy. So from that kinetic energy, or you already have the kinetic energy directly. So kinetic energy is equals to the gravitational potential energy. Kinetic energy is 0.86 and gravitational potential energy is mgh. So you have m and g, so you can work out h. M we calculated in the last part. That is for part C. Then the distance between the point P and the center of the sphere is 0.93. When the sphere is at position Y, the string is at an angle theta. Show that the theta is 47. How you can show it is 47? Like it is making a triangle. You work out this height. What is this value for the height when you calculate the value of h? So value of h is 0.29. Okay. So value of the h is 0.29, 0.29. What we need, like we'll just make a right angle triangle. As we need this theta, this was 0.93. And what is new position? Like how much the height has decreased, the vertical, like what is this height? So how I work out the height which we calculated, it was 0.29. So what about this height? When I subtract 0. So it will be 0.64. So this is 0.64. And what about the length? Yeah. So 0.64. And what about this length? What is this length? The whole pendulum, which was at a height of 0.93, has moved here. So what about this length? So this will be 0.93. And here we have a theta. The theta here will be same as theta here. Or in short, I can say this height, like this height, when I subtract, will be equals to 0.64. And this length is 0.93. So I need the theta. How I work out a theta? Now it's a right angle triangle. So if it's a right angle triangle, this one is a hypotenuse for us, and this the angle is between the base. So if we have the base and hypotenuse, so we can use a cosine theta, which is base over hypotenuse. So cosine theta, the base is 0.64 and the hypotenuse is 0.93. If I need theta, that is cosine inverse 0.64 divided by 0.93. What's the answer for theta? What's the answer for theta? So it will be about 46.5 or 47. So 46 point, because we have to show it's about 47. So that's how we showed. Is it clear? The theta. The next part, for a sphere at position Y, calculate the moment, the turning effect about P. So this angle we work out it is 47, 46.5 or 47, about 47. Weight is acting downward. This weight will have two components. Like if we continue this line, this angle will also be 47. So this weight will have the two component. One of the component is with an angle. So that is equals to W cosine 47. And another component is opposite to the angle, that is W sine 37. W sine 37. So which component is sorry, W sine 47. Which component is responsible for a rotation or a moment or a turning effect? Is it W sine 47 or W cosine 47? About P. Which component? Is it W cosine or W sine? Because W cosine is acting at the same as the pivot along the line. No, no, it won't be just W. The W will have two components. The weight is, because see, the pendulum is at this position and this is the point P. The weight of the pendulum is acting downward and this weight is having the components. One of the component is acting like theta is here. So this is the W cosine theta that is acting same as direction of the pivot, means on the pivot it does not cause any moment. The moment is caused by W sine theta. So means the component of the weight which is causing a turning effect, that is equals to W sine theta. Because W cosine theta is in this way, which does not cause any turning effect. Weight is acting downward. So W sine theta, and what is the distance from the pivot? The perpendicular distance from the pivot. So this is the perpendicular distance from the pivot. So W sine, the component of the weight, is causing a turning effect. And how much was this distance? This distance was 0.64. Because we took the perpendicular distance from the pivot. I kept W and use a path. Okay, that can also be done. You can take the perpendicular component of the distance. That's also fine. So both ways it will work. Either you divide the weight into the component, like weight is acting downward. Weight will have the two component. One is with an angle, that is W cosine theta. Another one is opposite to the angle, W sine theta. W sine theta is responsible for the turning effect. Now the distance, what distance we have to take? As we took the component here, in the question, they mention for a sphere, calculate the moment about P. So its weight is acting downward. Weight will have the two component, horizontal and the vertical. So the component which is causing a turning effect, so we take a perpendicular distance from the pivot. So you took W sine and then you took this distance 0.64 we calculated. So multiply them, you will get the turning effect of the weight. Is it clear? The last one, state and explain whether the sphere is in equilibrium. To be in equilibrium, there should be no resultant force. But what will happen? There is always a resultant force acting on the sphere. Even though momentarily it is rest, but there's a resultant force, the weight is acting. So that's why, because to be in equilibrium, the condition is no resultant force. So it is not in equilibrium because all the places there is a resultant force, the weight is there. So we say it is not in equilibrium. Even though it is stationary, but not in equilibrium or rest. Tension won't be equals to, no, the tension, in what case the tension will be equals to, the component of the tension will be there, but when it is here, in this case, the weight is equals to tension. That's right. But when it is at this position, so there are components are there. like this is the tension, T is there. So here the component of the weight, which is W cosine theta, is balancing the tension. But still the component of the weight, which is W sine theta, is not balancing with any of the component. That's why it is not in equilibrium. When it is at rest, that is a moment that T is equals to W cosine. But W sine theta is still there. So weight is always acting, the resultant force is still there, all the places. That's why we don't say it is in equilibrium, even though momentarily it will be at rest. So this component is always there, which is never balanced. Is it clear? Any question or doubt? This was a weekly homework, first 10 pages. So I'll end the session and share the recording with you.